Right, so in this next section, in section 4.3, we are going to talk about modeling linear trends. So in the last section, we talked about the strength of the linear association. In this section, rather than interpret the data themselves, we're actually going to model the data set and then interpret the model. So this is directly going to tie back again to what we've seen in previous algebra courses where we're thinking about equations of lines. So that's one of the reasons, again, that skills check homework had so many things to do with equations of lines, talking about slopes, intercepts, and things like that, because that's what we're going to look at as we start moving through this section. All right, so our first definition here is that of a regression line. All right, the regression line is a tool for making predictions about future observed values. It also provides us with a useful way of summarizing a linear relationship. It is also known as the line of best fit or the least squares line. So our regression line can have, again, if we're looking at different sources, it can be referred to as different things. Remember that the x-coordinate is the independent variable, and our y-coordinate is the dependent variable. Right? Again, one of many different terms for each. Right, so let's look at an example to kind of visualize what we mean by the regression line. Right, so the regression line summarizes the relationship between the width of the book and the number of pages for a small sample of books. The equation for the line is predicted width equals 6.22 plus 0.0366 pages. Right, so what we see here in this picture is the data set that this came from and the line of best fit, our regression line. The reason we call it a line of best fit is because it tries to go through, or it should go through, pretty much the middle of our data set. So it fits the best between all of our values. It's called a least squares line because of the way we actually do some of the calculations for this. Also, in addition to that, if we look at our equation, we're thinking something kind of algebraically along the lines of y equals mx plus b. So this doesn't look exactly like that, but it does have all of the same pieces in this equation. And we'll talk a little bit more about that when we actually start doing the calculations. All right, so in this example, an instructor is wondering if he has room on his bookshelf for one more book. He has 20 millimeters of space left, and the book he wants to buy is 598 pages. The regression line summarizes the relationship between the width of the book and the number of pages. Will the book fit? Okay, so what we're going to do is we are going to take this value of 598 and we are going to plug it into this predicted width equation. Okay. So predicted width equals 6.22 plus 0.0366 times our 598 pages. If we go through and do the calculations, type it into your calculator all at once, or if you're doing it in 2 steps, multiply, then add, we get 28.1 millimeters. All right, so looking at this, will the book fit? Well, we only have 20 millimeters of space left. Right, this is much larger. So we're going to say no. The prediction is that the book will be too wide. Right. One thing to mention here, the actual width of the book may vary. But it seems that the book will not fit. Right, so this isn't an exact value or answer. Remember that this is just a prediction. So the actual width may be slightly different than what we just got for our calculation, but this calculation is enough to answer the question. Right, so down at the bottom, the regression line in context. One of the uses of the regression line is to make predictions about what y values can be obtained for particular x values. But we are also going to analyze our slope and our y-intercept. So far in this first example, we've just seen making a prediction, one use of our regression line. And then as we continue in this section, we are going to take a look at our other pieces of our regression line. We're going to look at our slope, we're going to look at our y-intercept, we're going to talk about doing the calculations, and go through and kind of cover this topic in great detail.